as an organization. And how many of you are going to the luncheon? Okay, we don't know each other.
Okay.
Okay, like when we're there, no. I'll be up front. No. No, we'll hug.
Can I get your autograph?
There's a luncheon to celebrate 20 years of excellence and all the things, and I would love nothing more than to take selfies with all of you guys later this afternoon while we're there. Henry?
So can I take a Sharpie and get your signature on my face?
No. No. Let's see, papers. There are papers. Here you go. Okay. Rebecca, not here. There is a Thanksgiving break homework assignment.
Yeah.
It is 15 multiple choice questions on implicit differentiation. You guys are going to be fine.
I'll do that Saturday.
It should take no more than 1 hour total. Oddly enough, I don't see anyone writing this down. This is weird for me. Okay, so assignment number 62, 15 multiple choice questions. I will tell you right now, if you don't have work for each of those 15, don't even bother turning it in. Be like, oh, I did all in my head, liar. No, I know what happens when you have all these multiple choice questions, Rubio. Not you, others. Others. Okay? And there will be no lunch support today. I won't be here. Now, of course, all the ambassadors, if you're coming up and you're like, I'm quiet. No. No, we're not going to be having conversations about calculus at lunch. I mean, we'll know each other, but we're not going to be like, I'm missing a sticker.
When you're giving a speech on the right.
Oh, I'm not going to be giving a speech now. No, nobody wants that. And it's my wedding anniversary today.
Aww.
Yep.
I'm going to call you.
16 years, and those of you that are going to lunch will get a chance to meet Mrs. DeRozier and see just how smoking hot my wife is. Alright, that's right. Alright, so homework check, let's go. Okay, now it is possible that your answers are going to look a little different from mine because maybe you simplified differently. Or maybe you didn't simplify. Karina, are we filming? Okay, good. Alright, so number 1, x squared plus y squared equals square root of 7. You took a derivative, 2x plus 2y dy dx equals 0. We're going to solve for dy dx by subtracting 2x, dividing by 2y dy dx equals negative x over y, and I would expect every single person to get this one right. Everyone's getting this one right. Okay, number 2, xy plus x plus y, product rule. Little ugly. Okay, if you made a mistake, it's here. Your product rule is 1 times y plus x dy dx plus 1 plus dy dx equals 0. When you collect your like terms, you get your dy dx's together and you factor. Things that don't have a dy dx move to the other side. We divide dy dx equals negative y minus 1 divided by x plus 1. Okay. Number 3. You take a derivative, 1 over 2 square roots of x equals 5 times 1 over 2 square roots of y dy dx. I want to solve for dy dx. I multiplied by 2 square roots of y. You don't have to. I did. It works. dy dx is 1/5 times square root of y over square root of x. Number 4, dy dx equals 1 minus y over x minus 3. Number 5, I'm interested to see what happened here. ax squared minus by squared equals c squared. Now I'm throwing in x's and y's and, oh my god, a's, b's, and c's. Parameters. But the derivative of ax squared is 2ax. The derivative of by squared is 2by dy dx. The derivative of c squared is 0. Did everybody have 0?
Yes.
Nobody had 2c.
No.
Oh, good. Okay, dy dx equals ax divided by dy. Okay, BC friends, if you could find whisper mode, that'd be great. Okay, number 6.
Yeah, no.
Derivative of x times natural log of y, you need a product rule. 1 times ln of y plus x times 1 over y dy dx plus 3y squared dy dx equals 1 over x. I multiply by x times y because that's the common denominator and it makes me happy. I'll check out what you did with number 6. Number 7, I got a little tricky. It's 0 because cosine squared of y plus sine squared of y, you guys should know is 1. It's that Pythagorean identity. When you take the derivative of 1 is 0, dy dx, plus 0, so dy dx is equal to 0. And finally, dy dx is equal to the negative of x minus a divided by y. Okay, and I know there was a round 2. I'm going to skip round 2 for right now because I want us to get rocking and rolling. I need to take attendance. So if you could just put that in the middle of the table, please. That would be great.
Oh yeah, negative.
Alrighty, friends. Alright, page 41. Here we go. Now, this part's going to be maybe a little bit awkward because 4th period I'm leaving early. So the 4th period class is going to watch this part live and take notes and do all of the things. So it just might feel a little bit different. You know, I've got Kevin in that class. You seem to know him well. Harlow, it is a thing, isn't it? Kevin, Carlos, Juan, Jose P. I gotta keep them engaged all the time. So I might just call on them from time to time because Mr. Corrales is going to be with them. All right, so here we go. On page 41, this is the second free response question involving implicit differentiation. We're going to do this. We're going to do multiple choice. Everything's going to be good. Sad news. Sad news. I have nothing new to teach you all today. No, sad. Sad. Because this is all stuff that you know already. It's just an opportunity for you to get really good at this. So, a couple of reminders when it comes to implicit differentiation. You will never be given the graph. Ever. I've never seen the College Board do that because you're going to be tempted to answer questions based on the graph. I'm giving you the graph just so that we can know what's going on. All right, so here we go. For the rotated hyperbola described by x squared minus 3xy plus y squared equals 1, prove that dy dx is equal to that. You guys should know exactly what to do. A nice opening problem to get you started. I want you to prove that this is the derivative. So what are we going to do?
Find the derivative.
You're actually going to go find the derivative. You're going to do all the manipulations that you need to say finally dy dx equals fill in the blank. Take a minute, show me what you can do. Yeah. Right, but the good news is you have it in front of you. So I'm not too terribly worried about that. I also have some thoughts about what I want to do in this next round of videos. All right, Karina, I'm going to go over here. Okay. X squared minus 3xy plus y squared equal to 1. I know the 4th period class, they're working on this right now. Okay, so if I'm going to take the derivative with respect to x, the derivative of x squared is going to be 2x. No surprise here. Minus, and I hope you guys are actually doing this, I'm going to write minus the derivative of 3xy because this is going to be the hard part, right? This is where you have to do product rule and other crazy things are happening. Okay, plus derivative of y squared. Diego, what do you get for me?
Derivative of y squared?
Uh-huh. Wait, the derivative of y squared would be what? 2y.
And dy over dx with respect to the...
Yep. Equals derivative of 1? 0. That's a great first move. Life is good. I'd expect everybody's feeling really comfortable. Okay, Flora, how do you feel about taking the derivative here, the 3xy? Okay, tell me about your product rule. A derivative of 3xy.
So you would do is 3x times.
Okay, so you're looking at this as 3x times y. So tell me about your product rule.
I did 3x times the y over x.
Okay, so I hear you saying 3x times dy dx, and that's fine, but tell me what you do next.
You add the derivative of 3x, which is 3
Yep.
times y.
Okay, times y. You scared me a little bit because you're doing it in a slightly different order. I bet most everybody else has 3 times y plus 3x times dy dx. The good news with the product rule, it's really forgiving. You can switch the order, it's addition, it's commutative, sorry. Okay, so we've got 2x minus all that, plus 2y dy dx is equal to 0, and I hope I just did something that worries somebody in the room. I just did something that just about guarantees you're going to get this wrong. Daisy.
You're gonna put in parentheses in front of the 3x and
Yeah.
the 3y.
And after the 3y, right? Because all this in the parentheses represents that derivative that you found. And so I have to distribute the negative through. From here, it's just a little algebra party. 2x minus 3x dy dx minus 3y plus 2y dy dx. 0. I need some algebra. Find dy dx. Oh, there it is. Whoop. There it is. The terms that have dy dx, I hope this is becoming natural for everybody in the room. The terms that have dy dx, we keep them on one side. Terms that don't have dy dx, send them to the other side. So I've got, yeah.
How come you didn't combine the negative 3y and the 2y?
Why didn't I, oh. The negative 3y and the 2y? This 2y is getting multiplied by the dy dx, so they're not like terms. So I've got negative 3x dy dx. I've got 2y dy dx. Gotcha. Move the 2x. Move the 3y. I'm going to factor out dy dx. And then the last move, we're going to divide. So dy dx is equal to negative 2x plus 3y over negative 3x plus 2y. How many guys were like, you're good with that? You've got this under control? 2 people, maybe 3, maybe 4. Okay, feeling maybe pretty good. Now, I think, have we actually finished this off? Is this exactly the derivative that we need?
No.
Is it exactly the derivative that we need?
Yeah.
Jeanette's saying no, why not?
Wait.
Is it exactly what you're supposed to show?
No.
It's a different order.
We've got an order issue, right?
Yeah.
In the top, I have negative 2x plus 3y. That seems to match. In the bottom, I'm supposed to have 2y minus 3x. I've got negative 3x plus 2y. Sheila, are you worried about that?
No, because it's the same thing.
It's exactly the same thing. But you might want to just go one step further and say, okay, yeah, there we go. At this point, we're done. Full points. Life is good. Somebody give Kevin a nudge. He's probably falling asleep at this point. You think it's 1?
I flipped them right whenever I did the product rule. Is that
Uh-huh.
right? That's why it's different down there because of the product rule up top.
Ah, because of the way you did the product rule up here, it's a little different down here. But everybody's okay. It all works out the same. I really want implicit differentiation to be comfortable and make you feel good, Chris, and be like, yes, this I've got. A, done. B, determine the equation of the tangent lines at the X-Intercept. Go for it. Show me what you can do. I want to be a proud papa. Carlos, you doing okay? Abraham, make sure you take care of Carlos. I gotta take care of 2 class periods and kids in Ohio. Oh, good question, Marilyn. Do you look at the graph? No. No! You wouldn't have a graph. Why did I put it there? To mess with your head. Determine the equations of tangent lines at the X-intercept. Shame. Shame on you. if you are looking at the graph and saying, there they are, negative 1 comma 0, 1 comma 0. Shame, because...
It's asking for the equation.
No, that's not why.
You're not supposed to
You're
look
not
at
supposed
that
to
graph.
look at the graph.
You won't even have an opportunity to look at the graph. They won't give you a graph. But is everybody okay that there are clearly two x-intercepts?
Yes.
Okay, if there was no graph, hands on this, what would you do? How would you find the x-intercepts? Julissa, what would you do?
We set the y is equal to 0.
Okay, x-intercept means the y value is equal to 0. Now when you say you set the y value equal to 0, where?
At the x-intercept.
Like, where do you use this fact that y is equal to 0?
Oh.
In the derivative?
Original.
Back into the original, because this is the guy that establishes the connection between the x's and the y's. So y is equal to 0, x squared minus 3x times 0 plus 0 squared is equal to 1. What is that? X squared is equal to 1? If x squared is equal to 1, then x is going to be 1 or x is going to be negative 1. And I hope everybody's okay with that. And hey, good news, it matches the graph. I didn't lie. No lies here. So I've got an intercept at 1 comma 0 and an intercept at negative 1 comma 0. And you found them the right way without cheating, which is good. So finish it off. Right, we're back. This is determine the equation of the tangent line at the x-intercept. So I need all right, seeing some good stuff. Juan, how you doing? Hopefully Juan's still awake here. Okay, dy dx at 1 comma 0, x is 1, y is 0, negative 2 times 1 plus 3 times 0, 2 times 0 minus 3 times 1. We'll think that's negative 2 over negative 3, 2/3?
Yes.
So equation of my tangent line, L of x equals 2/3 times x minus 1 plus 0, and I hope this is just popping and comfortable, and you're like, I feel good about my calculus skills again. Okay, now dy dx at negative 1 comma 0, we're going to plug this in, negative 2 times negative 1, 3 times 0, in the bottom, 2 times 0 minus 3 times negative 1, is that 2/3?
Yes.
Okay. Now, I bet, I'm wondering how many of you have on your paper right now these two things. I see 1, I see 2 or 3, 4, 5, all these happy people. We have a problem. We have a problem. One more time, how many of you guys have both of these? You have L of x is equal to this, and you have L of x equal to this other thing. What could potentially be a problem here? Andy, what's the issue?
You have to change the elements.
Why?
Because I'm gonna get confused.
You're going to get confused because you're saying L of x equals this. Oh, and by the way, at the exact same time, L of x is equal to this. You don't want to do that. You're over-defining L of x. So what I like to do, I might just call this like L sub 1 and L sub 2 to say these are two different ones. Maybe I want to go like, this is C of x and this is M of x. Carlos, that was for you, right? Doesn't matter. Just don't use the same variable in both places. I think we're good with B? Good. All right, C. Yep. Evaluate d squared y dx squared at the x-intercepts. Oh, you guys know what I want here. Second derivative. D squared y dx squared means second derivative. It does not mean take the derivative and square it. No. Second derivative. Great. You're going to find the second derivative. That means you're going to go to the first derivative. You're going to find that derivative, and all is going to be well. Okay, I know it says to find the second derivative at both of the intercepts, We're only going to do one because I want to save some time here. Okay, go for it. Show me what you can do. I'll do a quick lap.
Which one?
1 comma 0. Anybody else want some extra paper? I know this one's a little bit long. Okay. Hello. Hi. High scoring.
Oh no, but like after
Second derivative. Oh, I can't wait to see it. All right. Oh, there it is. Second derivative. I need a little quotient rule. D squared y dx squared, so low. D high would be -2 plus 3 times dy dx. If everybody's okay with that. 2y minus 3x times d high is -2 plus 3 dy dx minus the high, -2x plus 3y d low, 2 times dy dx minus 3. The denominator low, 2y minus 3x the whole thing squared. Just give me a quick thumbs up. How are we doing?
Okay.
Second derivative, we got this? This is probably a 2-pointer. Okay, now I need to know what's d squared y dx squared at 1 comma 0. And for those of you that are super fast, do it for -1, 0 as well, but at least 1 comma 0. X is equal to 1, y is equal to 0. I'm just going to plug in. 2 times 0, 0. Minus 3 times 1, I think. We get -3 in the first one. -2 plus 3 times dy dx. Let's put a little pin in that for now. 3 times dy dx. Minus -2x plus 3y. -2 times the x, hold on, Daisy. Plus 3 times the y is -2. And then we have 2 times dy dx minus 3. In the denominator, 2y minus 3x. 2 times 0 minus 3 times 1 is -3, and we get a square it. Daisy, what were you going to ask? You good?
Yeah.
Okay. We're not done. We got a problem. You got to figure out what dy dx is. But it's not just any old regular dy dx, it's dy dx at the point 1 comma 0.
We have it? Oh, we have that.
We have that already.
It's 0.
2/3.
You said that out loud.
2/3.
dy dx at 1 comma 0 is 2/3. We figured that out back up here. And in part B, dy dx at 1 comma 0 is 2/3.
Oh.
Awkward, yeah, I know. All right, so -3 times -2 plus 3 times 2/3 minus -2, 2 times 2/3 minus 3, all over -3 squared, which is 9. Yeah.
What if they give you like different L of x? How will you know which one to plug in dy and dx?
Well, I hear your question. You're like, how do you know that it's going to be 2/3? What if they gave you a different point? Then if they gave me a different point, I'd go back to my derivative. I'd plug in there, and we'd be done. And all the friends are okay? Now, if this is free response, we can leave it. And if you guys are okay, let's just assume it's free response because I don't want to monkey around with the fractions. All right, here we go. Part D. Here comes the new idea. You're going to want to give yourself a little bit of space.
A little more?
A little more space, yeah. Part D, show that at no point on the curve has a vertical tangent line. No, not the same as saying show that the graph is continuous. And this is one of these things that's going to mess with your head a little bit. Just go with me, it's going to be all right. Show that no point on the curve has a vertical tangent line. Now there's always some calculus student that says, okay, what do I know about a vertical tangent line? Vertical tangent line looks like this. And then they look at the graph and they say, is there any place where there's a vertical tangent line? Do we see it? Do we see any places where there's a vertical tangent line? No. What's wrong with this approach? Gonzalo, what's wrong with this approach?
With or without the graph?
There's no graph. What's wrong with this approach?
Oh, never mind. I was talking about the graph.
What's wrong with the approach?
Since you don't have a graph, you can't be like, oh, I cannot.
Because you wouldn't be given a graph, you can't look for vertical tangent lines this way. Is everybody okay? So here, a different approach, it's called proof by contradiction. It's a math thing. They want you to show that there's no point on the curve with the vertical tangent line. What we're going to do is we're actually going to assume there is a place with the vertical tangent line. Okay, stay with me on this. This is a brand new big brain idea. You want to show that there is no point, so you flip the question and you say, let me assume that there is. If you have a vertical tangent line, then what does that mean about the derivative? The derivative is undefined. What has to happen, just stay with me on this, the derivative would have to be undefined. What has to happen for the derivative to be undefined? Not 0 over 0. A number over 0. What that means is the denominator is equal to 0. 2y minus 3x is equal to 0, but your numerator isn't equal to 0. We're just going along to see what happens. Getting here already would get you some points. You're trying to figure out, is it ever possible that 2y minus 3x is equal to 0? The tough part is you've got one equation and two variables. So you can't give me a number. You can't say, oh, x is 4 or y is 2. You can't do that. What you can do is get a little creative with the algebra and say, well, if this is true, if this relationship between x and y is true, what also is true is this guy up here. We've got two different equations that have x and y in them. You should be having flashbacks to Algebra 2.
Equal them to each other.
You not set them equal to each other. You want to maybe do substitution. If 2y minus 3x is equal to 0, well, what's also true?
Y equals
Negative, positive.
Well, let's be careful. 2y equals 3x. So y is equal to 3/2 x?
yes.
Right, we're going down this assumption. Well, if y equals 3/2 x, then I can take that information, I can plug it into this equation, and let's see what happens. X squared minus 3x times y is 3/2 x plus y squared is equal to 1. Y equals 3/2 x. I went into the original equation and plugged it in. And I bet nobody sees anything wrong yet. Let's keep going. X squared minus 3x times 3/2 x is the same as 9/2 x squared. 3/2 x times 3/2 x is 9/4 x squared. I'm a fraction killer. I'm going to multiply everything through by that common denominator. If I do that, now I've got 4x squared. 4 times 9/2 I think is 18. 4 times 9/4 is 9. That's probably still looking good for everybody in the room. 4x squared minus 18x squared plus 9x squared is negative 5x squared, which means that x squared equals negative 1/5. I'm just doing some algebra. Not even any fancy algebra? Just doing a little bit of algebra? If there's a vertical tangent line, then the derivative's undefined, which means that the denominator is equal to 0. We solved that and said that means y equals 3/2 x, and we plugged that into the initial relationship, and by combining like terms and doing a little bit of algebra, x squared equals -1/5. Anybody see any problems with this? Oh my gosh, look at all these great, big, beautiful hands. Andy, what's the problem?
Is it that since it's not equal to 0, it means that there is no vertical tangent?
That's not the issue. X squared equals -1/5. What number squared is equal to -1/5, Gerson?
No, you can't have a negative square.
You cannot square a number and get -1/5. So the only way I have a vertical tangent line is if x squared equals -1/5. But what did we just decide?
You can't do that.
This is not possible. So what? If x squared equals -1/5 is not possible, what happens? There is no vertical tangent line. Because if there was, then I'd have to be able to solve this equation. I can't solve this one, so this is false. So I'd say something like, therefore, there is no vertical tangent line. Nicely done. Not something I would expect anybody to just do on their own. Not even something I plan to like heavily assess, but something I wanted to expose you guys to. All right. So with that said, we're gonna continue filming, but fourth period, they're done at this point. What I want you guys to do, ooh-wee. All right, in honor of the new Justice League movie that is coming out, that I will be seeing tomorrow night with my daughter. Okay.
And let's begin fighting.
Where the road good? Can you go?
Can you get, no, you have to earn the flash. Okay. Yeah, see, I don't know you guys.
No.
Why
do you get with the
Sorry. Okay. So in honor of the Justice League movie that is coming out tonight,
Yeah.
or came out, sorry, I need you to form a Justice League of your own. Okay? So whatever superhero you are, Green Lantern, what do we got back there? Flash, Batman, we got Wonder Woman. I need you to, Hawkman. Shut up. I need you to regroup, form a Justice League of your own. No more than 4 people. Make it happen, please. Move.
A group of plastic.
Let me talk to him.
You got the Green Lantern. You got the Hawkman. Dude. No, come on, bro.
Oh, yeah.
And a Superman.
Bro, I already got my superhero team, bro. I don't need no Wonder Woman. What is that? I need to be Superman.
You can trade with him. We don't want to talk.
Jardo needs a team.
Oh, we need a Wonder Woman. We don't need Hawkman.
Hey, Hawkman might be poopy, but I can make him the best. Look at that. That's the man.
All right. Have a seat, please, in your group of 4. We are wasting time that we don't have.
I can turn back time.
Okay. You have
Stop talking to my Hawkman, boy.
4 minutes in your Justice League grouping to solve the 12 o'clock and the 3 o'clock problem on the next page. 4 minutes. I hope you formed your Justice League well.
No. We have Hawkman. Hey, Hawkman is the best man.
Hey, we have wait, we don't have any
You don't need Superman.
Where's the overpowered hero?
Yeah, who needs overrated heroes?
I would use
The flash can run back in time.
I would much rather
Use the speed force to answer this question.
Yeah.
I need a pencil. I can fly my way to make. I'll fly my way to the answer. All right.
Just imagine the answer.
Dang, I lost my pencil. Oh, did I leave my pencil? Yeah, you use this. Can you throw my pencil over here?
Yeah.
Wait, this is Thursday's unit test. Does that mean
Just focus on the problem.
Ohio 1 point.
There won't be a unit test on Thursday. Thank you for being so focused. You get on completely the wrong thing.
If x cubed is 3xy plus 2y cubed you gotta take the derivative, dy dx. Yeah, you gotta take the derivative. I don't want it. Did I ask you?
You know what are you again? Batman.
I'll just tell my butler to do it.
Isn't there like an alternate universe that
Angry Lantern too.
This universe, bro.
Oh yeah,
Okay, we seem to have a very dysfunctional Justice League over here.
What? It's because it's me, bro. Hawkman. Come on, bro.
get it.
Wait, how you find the derivative of dy with dx of
Batman and Green Lantern.
When you take out this dy and dx, you put these together. So like your answer.
Isn't this supposed to be product?
No, but like he switched it. He put all the three
Yeah, you gotta get dy dx in one side. But I'm telling you, how did you get this?
Because every shot you take
That we weren't as synced up as we normally are right now.
Take y first.
Obviously, that was like a really
Then you do 3x times y.
You don't need to write times.
3x
I remember
times
the
y.
video that I had from last year.
That means I must take the derivative.
I haven't done it. I'm not angry. It's just
3x. Oh.
I thought we were synced up as well as we normally were. I didn't realize that we were. This is not your problem to solve.
Can you take it out first without taking the derivative?
So that's not what this is. This is not dy dx. This is ddx. Meaning you're going to take the derivative.
I'm not gonna do
So you're just gonna do a notation of the
Stop touching my Hawkman and Hawkwoman. Bringing the voice of feminism.
Is there a woman in Green Lantern?
there's a red lantern?
The one. Oh yeah.
Alright, let's get on that spirit card.
My weakness is yellow.
Oh, you know the first Green Lantern.
Yeah. My icon is
This is a good lamination. Extra.
Oh, it is that. I got it right.
Alright, spoiler alert.
No.
There they are.
Oh, wait, no.
Okay, so if all goes well,
I think he is.
you took your derivative on the first one and you got 3x squared plus 3y plus 3x dy dx plus 6y squared dy dx is equal to 0. This should be something very comfortable for everybody. Terms that had the dy dx are the 3x and the 6y squared, so I keep those on one side and I factor. Terms that didn't have the dy dx are the negative 3x squared and the negative 3y. Those go to the other side. And I get dy dx equals negative 3x squared minus 3y over 3x plus 6y squared. It's a great answer. And I'm going to hide it from you. You're going to have, like, and how they're going to hide it this time is through a little bit of factoring and then a little bit of canceling.
What if we plug in like a value?
That scares me more than a little bit. You really need to attack. I get it. You're trying to use like maybe some like SAT skills. I would caution you against doing that in a calculus class. There's a lot of ways for it to go wrong. Really, really wrong. Okay, so second one, x squared plus xy equals 10. If you found the derivative, you've got 2x plus 1y plus x dy dx is equal to 0. They want you to find the derivative when x is equal to 2. So the problem is that your derivative involves both x's and y's. They told you x is equal to 2. Where do you get the y value from?
You play it over.
Whenever you have one of the values but not the other, the solution is the same. You go back to the original equation. You go back and you say, okay, x is equal to 2, so 2 squared plus 2 times y is equal to 10. You get y is equal to 3, and then you plug it in to finish it off, and you're going to get negative 7 over 2. Okay. Based on all the looks of shock, I think you guys didn't have enough time to get to the second problem. I got to tell you, when it comes to a quiz or a test, you would have 2 minutes per multiple choice question. So you have to work faster. I know it's the Friday before Thanksgiving. You're just going to have to work faster. All right, show me what you can do with third one. 2 minutes. Maybe. Hi, Henry.
So I understand when you put everything on the side, and then you get rid of it.
You factor out the dy dx. Right? That's why you want to get the terms that have dy dx on the same side so that you can factor them out. And then you divide by the set that doesn't have to get dy dx.
Like I know when you negative yeah, why is it negative? You should have told me yesterday. When I did I messed up somewhere with your Hawkman carries the team, boy. But I see. When you get the second derivative, you just get -1. Not really. Sir Batman, come on, give me this guy. Well, they're smart.
For like the
Is that the first derivative?
Yeah. Okay, so hold on.
Why did you divide?
Walking around, just about everybody found the first derivative corrected. dy dx equals negative x over y. Your first derivative, 2x plus 2y dy dx is equal to 0. To solve for dy dx, subtract the 2x, divide by 2y. Most people seem to have gotten here. Now you need the second derivative. Where does that come from? By taking the derivative of this derivative. I'm seeing way too many people telling me that the derivative is negative, the second derivative is -1. If you're going to find the second derivative, what do you need? You need the quotient rule. You need the quotient rule. Quotient rule, low. D high minus high. D low. all over
Low.
That's your second derivative. Specifically, you need the second derivative at the point 4, 3. X is equal to 4, y is going to be equal to 3. So I've got 3 times -1 minus 3 minus negative x. What is that? Plus 4 times dy dx over y squared. And we're running into this problem again if we don't know what dy dx is. What's dy dx? dy dx is negative x over y, so what's dy dx at this point? Negative 4 over 3. So I can replace the dy dx with negative 4 over 3. Now you are going to have to simplify. It's multiple choice. You have to be able to do this. So take a couple seconds, finish that off. Negative 3 plus 4 times negative 4/3 is negative 16/3 over 9. You're going to need a common denominator. Common denominator is going to be 3. Negative 3 is the same as negative 9/3. So negative 25/3 divided by 9. Little keep it, change it, flip it. Negative 25 over 27. Yes. What? Negative 25 over 27. So your right answer should be A. All right. 2 more minutes. See what you can do the next one. I have faith in your smart particles, Paul.
Hotman is my alter ego. My IQ.
Okay, so that's a good stuff. 2x plus 2y dy dx is equal to 0. dy dx is negative 2x over 2y. Negative x over y, no surprise. We've done this before. D squared y dx squared means second derivative. Little quotient rule again. Low d high minus high d low. Low, low. Maybe even want to clean that up a little bit. Negative y plus x dy dx divided by y squared. That looks like a great answer. And Paul asks, he's like, but what point? At what point do you want the second derivative? They're not asking you for the second derivative at a point. They're asking you for the second derivative everywhere. Everywhere. I've got this, and I have all these answers that I have no idea where they've come from. So again, what are they doing? What are they doing? Look at your answer and look at what those crazy College Board folks are offering up. Not a single one of them has this dy dx in there. Anybody know what dy dx is?
Negative x over y.
dy dx is negative x over y. So replace the dy dx with what it's equal to, which is negative x over y. And so maybe you get excited now and you're like, all right, cool. Negative y minus x squared over y divided by y squared. Oh my God, even that doesn't look like any of the answer choices. What else? Say them real quick. Negative y minus x squared over y. How about get a common denominator of 1? The common denominator would be y, multiply the top by y and the bottom by y. What you'll get is negative y squared minus x squared over y divided by y squared. You could do a little keep it, change it, flip it. So you're multiplying by 1 over y squared, and if you multiply by 1 over y squared, you get y cubed. Hey, that looks great. Oh my God, that's not one of the answer choices either.
You can simplify the y.
You cannot simplify the y's. You cannot cancel.
Square root of everything.
There's something really clever. Andy, what do you see?
Can you substitute the change it like the equation?
This is Andy's day. You were told in the beginning that x squared plus y squared is equal to 6. So guess what?
Oh my God.
Anytime you see x squared being added to y squared, that's equal to 6. So what do we get here? We've got the negative of that, so this is negative 6 over y cubed. A again. When in doubt, go with A. Okay, obviously you guys are running late. What teachers do I need to email?
Let's go.
Garcia. All Zeta. Okay. Wilson Garcia, Alton Gutierrez. My apologies. Have a great Thanksgiving. Karina, it's going to be okay.
Vamos to be. Have a good Thanksgiving.
I know what I'm doing. I probably it's gonna be okay.
That's all.
Yeah, quit.
I'm not running.
Respecting women. They were respecting women. And
I will figure it out.
Is that actually Mr. D have to watch nothing?
I'm a whole season and a half behind. I'm working my way through Legends of Tomorrow.
Man, your priorities are over.
Yeah, I know. Like raise a family, adopt a kid, rebuild a home, close the achievement gap.
It comes later.
I should watch Gotham more.
Yeah.
See you later.
Come over to my house. We'll watch.
Oh, what did I just do?
You should be alive.
You spell out, there's A-U-L-T.
Bye-bye. Yeah, they record it. And it was like this perfect, flawless, also what I need so I can leave 25 minutes early. Anything I can do? No, I'll figure it out. All problems have solutions. I have 52 minutes to figure it out.